So in this video, we're going to talk about how energy flows through ecosystems. Definitely a key idea in this ecology unit, really building off several of the other introductory videos that I showed, especially the one introducing energy and matter. So what we're really trying to show is that energy flows through ecosystems, and that it's a one-way travel. Energy will enter in one form. We'll see that that's sunlight in just a minute, and exits in a different form, heat, that will not be able to be recycled like we saw with matter in the carbon cycle video. Energy and matter are very different in this regard, and organisms need access to both, but how they both move through ecosystems is very different, so we want you to really contrast the two videos when you watch them. Here's kind of another attempt to give a really broad overview. This looks kind of overwhelming, but we'll go one step at a time. Energy enters as sunlight to producers who are capable of using that energy to make their own food energy stored in their bodies. Heterotrophs will access that energy by digesting it, by eating others, taking their food energy molecules and making it their own. And all organisms have to spend quite a bit of their own food energy just staying alive. And whenever they spend energy, that energy leaves their bodies as heat. You might be most familiar with this when you work out. Let's say you're on a treadmill and the treadmill says you've burned 300 calories. That's because you've taken 300 calories worth of food molecules out of your body, you've burned them, and that energy has left as heat. That's what made you sweat as you were working out on the treadmill. So let's kind of go through one step at a time and how energy flows through ecosystems. So photosynthesis is the process of taking the sun energy and converting it into food storage molecules in your body, what I'm calling here just kind of biomass. And I've already covered that producers or autotrophs are organisms who are capable of doing that. Just a very brief note, not all ecosystems rely upon autotrophs who use sun energy. Some are capable of using chemical energy to make new biomass energy as well. For example, on the ocean floor where the sun doesn't reach, they're going to have to use some other kind of energy available in their environment. But for most ecosystems, that's going to be sunlight energy, like on land or in streams or in the kind of the surface of the ocean. How do heterotrophs obtain their energy? By eating it, by digesting the food molecules of other organisms. And let's just kind of review the trophic levels of heterotrophy as well. We call you a primary or a first level consumer if you're an organism that directly eats plants, the kind of the first source of food. You're a second or secondary consumer, second level consumer if you eat the organisms that eat plants. So maybe in this case, a rat who eats a grasshopper. If you're the snake who eats the rat, you'd be the third level consumer. And if you were the hawk eating the snake, you'd be a fourth level consumer or a quaternary consumer. And it is true that some organisms, depending on who they eat when, might occupy different trophic levels. But really, we're trying to take kind of a broader look at how energy works with trophic levels. So that's why we wanted to introduce them here. And now we want to show you this energy pyramid idea. So the energy pyramid takes the trophic levels and kind of stacks them up and tries to estimate with the width of each bar how much energy is available as food to eat for each of the higher trophic levels and how much food energy producers generally have access to. And so what we really want you to see is that that energy amount greatly dwindles as you get higher up in the food chain. In fact, we have a way to approximate that. We call this, the rule of tens. The idea that maybe only about 10% of the total food energy available at the previous trophic level is actually available to the next trophic level. So maybe if producers have access to 10 million units of food energy at some point in their lives, that maybe only about 1 million units of that energy will be available to the primary consumers. Maybe only 10% of that, 100,000 units of energy, will be available to the second level consumers. And only 10% of that, 10,000 units, may be available to the third level consumers. And why is that? Well, but that's simply because maybe about 90% of the total food energy that a trophic level works with is spent by organisms of that trophic level. they have to stay alive. They have to do the things that they do: grow, reproduce, maintain homeostasis. And whenever they spend that energy, it leaves them as heat. You can't eat heat. That energy is no longer available to organisms of the next trophic level. You've already burned that energy. It's gone for the purposes of organisms who would want to eat organisms in that previous trophic level. So two ways of thinking about the rule of tens. About 10% is remaining in the bodies of organisms of a trophic level for organisms at the next trophic level to eat. Or you can think about it as about 90% of the total food energy is burned by organisms in a trophic level just to stay alive. And that really has consequences for how big of the populations you might see at each trophic level. If you think about the population video that we went through, you would expect that maybe the higher trophic levels to have the smallest size populations. Their carrying capacity is going to be the smallest because they have the least energy available at their trophic level, whereas producers are going to have a much more energy, a much higher carrying capacity, so a much higher population size. And that makes sense if you think about walking in a forest. Most of what you see are trees. Maybe you see the occasional herbivore, the squirrel kind of walking around. And you tend not to see very many carnivores. You tend not to see mountain lions or bears when you go out for a walk in the woods every day. So that is just kind of summarizing our idea of energy flow. Energy comes in as sunlight energy so that autotrophs can make new food energy through photosynthesis. Heterotrophs have access to that through digestion, and that everybody has to spend their food energy to stay alive, and when they do that, it exits as heat. And notice again the overall one-way direction of these arrows.